the existing power grid was installed and put into service in the 1950s. Since then, power consumption has gone up dramatically due to increased power demand. Pepco is responding to this increased need with a new state-of-the-art transmission upgrade. This process has taken many years to become fully integrated and is now being built. This new system is being installed with the future needs of the community in mind and is expandable to meet those requirements. The process to upgrade the system will take years to complete. What you are about to see is just one phase of Pepco's reliability commitment to the community it serves. It all begins with engineering. Pepco engineers have identified the needs for expansion of the power grid in the areas that are most critical. Evaluation of the best routes with the least amount of disturbance to the public have been determined and plans designed and reviewed by all affected municipalities. This process included coordination with other utilities prior to the beginning of construction. The design and construction has been developed so that there will be no service interruption to current customers. Once contractors have been selected, the construction can begin. Contractors are put through a vigorous vetting system to assure only the highest qualified companies are involved. Transmission underground construction runs only between substations and does not go directly to end-use customers. No work will be done on the poles you see on the street or wires to houses or businesses. The sequence of construction is as follows. Safety of the public and workers is the paramount concern of all involved with the project. Training of employees through OSHA classes, Pepco classes, traffic control classes, and other specialized working condition classes are critical to the success of the work. Safety meetings are held on a daily basis. All potential hazards of the day are discussed prior to the beginning of each day's work. Once engineering and design is complete, permits from local jurisdictions are acquired. Once permits are in hand, the physical construction can begin. Miss Utility is called to locate and mark all existing utilities that may be encountered within the excavations. It's the law. Engineers will now survey the work areas and provide layout for the construction to begin. This consists of wooden stakes offset to the work marked with the station numbers as relates to each work item. Paint markings are also applied to the surfaces close to the work areas. Cut sheets are developed to assist the workers with the proposed grades that need to be achieved to install the duct banks at the proper line and grade. Since most of the work will be performed in public streets, traffic control is set up to keep the workers and the public safely separated. Once traffic control is set up, the streets need to be saw cut to provide a clean edge for excavation. This will isolate the vibration of the work from adjacent properties. This also provides a clean edge for steel plates to be set in order to cover the work areas during off hours. Now it's time to start digging. Surface pavements will be removed to expose the earth below. Asphalt and concrete debris is removed daily and sent to local recycling facilities for repurposing as fill material. Excavation within the saw cut areas down to the bottom elevation of the proposed duct banks is performed with an excavator loading the earth spoils into a dump truck for off-site disposal. Trench boxes or other trench safety measures are installed to protect from trench collapse. Trench safety measures, in accordance with OSHA regulations, allow for personnel to enter the excavations and install the conduits that will carry the electric cables. Gas detection monitors are put into every excavation prior to personnel entering the work areas. This monitoring is used the entire time the workers are within the trenches. Once a section of trench is opened up far enough ahead, the conduit package can be installed. Due to the restricted work hours permitted by the local municipalities, steel plates are installed over the trenches on a nightly basis. The plates are welded together and pinned down to prevent them from slipping due to traffic. The plates are inspected during off hours to ensure they remain in place. The conduit package consists of PVC pipes and spacers to hold the pipes in place. The ends of each pipe are beveled on the inside edges to allow for the cables to be pulled through without damaging them. The PVC pipes are then glued together and all joints are sealed with duct tape. Once the pipe package is installed, thermal concrete is poured over it to complete the duct bank. This concrete is dyed red to identify the duct bank as an electrical utility. Once the concrete is set up overnight, it is surveyed by engineers to identify the top elevation for public record. The trench safety measures are then removed. Backfill material is placed over top of the duct bank up to the bottom of the pavement cross-section that will be installed to provide a new temporary roadway surface. The temporary roadway surface will remain until all construction is complete and a new permanent roadway can be installed. The manholes require a crane to set them and a larger trench safety system. A larger footprint is required to accommodate the size of the manhole, as well as to provide adequate space for a crane to safely place it. Once the manholes are installed and the conduit duct banks are completed between them, the PVC pipes are checked for continuity via the use of a mandrel being pulled through each pipe between manholes. The conduits are then videotaped for record. A pull string is installed in each conduit to assist in the pulling of the cables through the system. After the system is complete, inspected, and accepted, the final roadway restoration can take place.